Up until now, if we've had questions that involved brackets, we've always had to expand them before we can differentiate. But today we're going to learn the chain rule. To use the chain rule, we're going to have to substitute into our equation u. And instead of finding dy over dx, we're going to be differentiating dy over du. So we have a little formula here at the top of the page. And if I'm wanting to find the dy over dx, but I'm substituting u into my equation, I'm going to find dy over du instead. Now, I still want my final answer to be in terms of dy over dx. So if I multiply that by du over dx, you can see that the du's, just like algebra, those du's would cancel off and we would get the dy over dx that we need. Okay, so let me show you how that works in a question. If I want to find the derivative of 3x minus 2 all to the power of 5, so that's going to be y equals 3x minus 2 to the power of 5. Because I do not want to expand something with a power of 5, that would take a really long time, I'm going to do a substitution. I'm going to say let u equal the 3x minus 2. Okay, so that means I'm going to get y equals the 3x minus 2 is going to become u to the power of 5. Now I can differentiate that, but I'm not differentiating x, I'm differentiating the u. So I'm differentiating y with respect to the u, and that equals, bring the 5 down to the front, u stays the base, and subtract 1 from the power becomes a power of 4. Now I also need to find the derivative of my u equation over here. So du, differentiating the u with respect to x, would give me simply the 3. So now that I have those two derivatives, I can use my chain rule. So therefore, dy over dx is going to be equal to dy over du times by du over dx. So dy over du, that was this one over here, that was equal to 5u to the power of 4. So 5, instead of using the pronumeral u, I'm going to sub back in that u was equal to 3x minus 2, and that is to the power of 4. Okay, just subbing the u back into that. Then I want to times that by du over dx, which we worked out over here, was equal to 3. So it's just times by 3. To tidy that up, I can multiply 5 times 3 to be 15, and then the 3x minus 2 all to the power of 4. And that's how you do the chain rule. Let's do another one of those. Differentiate 3x squared plus 4x minus 1 all to the power of 12. So I'm going to call that y equals 3x squared plus 4x minus 1 to the power of 12. Whatever is in that bracket, that's what our u is going to be. So over here on the side, u is going to be 3x squared plus 4x minus 1. So I'm going to sub that in. Y equals u to the power of 12. I'm going to differentiate both of my expressions here. So dy over du equals, bring the 12 down the front, u subtract 1 from the power is 11. Now to differentiate my u equation, it's du over dx equals, the 2 comes down the front, times this with the 3 to give us 6, x, subtract 1 from the power would just be 1, and plus 4. So now I'm ready for the chain rule. dy over dx equals dy over du times by du over dx. So dy over du was 12u to the power of 11, but remember to sub back in that u is equal to 3x squared plus 4x minus 1. Then I times by du over dx, which was 6x plus 4. And there it is, that's my answer. Let's try one more of these on the next page. Question 3, I want to differentiate the square root of 4 minus x. So that's going to be y equals square root of, actually instead of square root, let's change that to be 4 minus x to the power of a half. That's going to be easy to differentiate. So I'm going to let u equal the part that's in the bracket, which is the 4 minus x. To differentiate, or before I differentiate, I will have u over here to the power of a half, and then I can differentiate dy over du equals, bring the half down the front, leave the u, subtract 1 from the power, gives negative a half. So I could write that back into positive index form. The u to the negative half would need to go to the bottom of the fraction. The 2 is already there. U to a positive a half. Or I could put that back in square root form. Square root of u. Differentiating the u would be du over dx equals, the 4 is a constant which will disappear, so it's the negative 1 that's in front of that x, which will be my derivative. Using the chain rule, dy over dx equals dy over du times du over dx. dy over du was the 1 over 2 square root u. Instead of u, sub back in that u was equal to 4 minus x. That needs to be multiplied by minus 1, but instead of writing it like that, multiplying by minus 1 will just make it negative on the top of that fraction. Okay, so now that I've shown you that rule, the chain rule, there is a shortcut that you can use so that you don't always have to sub in the u all the time. And this is it as a rather interesting looking formula here. What you do, if I want to differentiate y is equal to some function to a power of n, to differentiate dy over dx, the n, the power, always comes down the front. You multiply by the derivative of the function, and then the function itself is multiplied with 1 subtracted from the power. Okay, so let's try that. If I want to differentiate 6x take away 1 all to the power of 11. So if that's the y equals dy over dx, I can go straight to the derivative. The rule says bring the power down to the front, which is 11, multiply by the derivative of the function. The function is the bracket, so the derivative of that bracket is just the 6 that is in front of that x. So I've got 11 times 6. Then you multiply by the original function, 6x take away 1, and subtract 1 from the power, which is 10. So I can tidy that a little bit. 11 times 6 is 66. 6x take away 1 to the power of 10. And that's the short method. Let's do that again. Differentiate 3x plus 7 to the power of 5. So dy over dx equals, the power comes down to the front, multiply by the derivative of the function, which is the derivative of the bracket, which will be the 3. Multiply by the bracket, and subtract 1 from the power. 5 times 3 is 15. 3x plus 7 to the power of 4. Question 6. Remember, this is another way of being asked to differentiate something. It's saying find d over dx, and this equation here is what I want to find the derivative of. So before I can differentiate it, I need to get rid of the fraction. So I can bring the bracket back up to the top if I give it a negative power. Okay, so now I can do the derivative part. I bring the power down to the front, minus 3, times by the derivative of the bracket, which is also 3. Leave the bracket and subtract 1 from the power, which is minus 4. Then to tidy it up, minus 3 times plus 3 is negative 9. And we do have 3x minus 2 to the power of negative 4. But where possible, we want to put the question back into the answer back in the same form as the question. So the question had positive indices, was in fractional form. So I want to write this with the minus 9 on the top, and I can put the 3x minus 2 to the power of a positive 4 on the bottom. Question 7, differentiate. So I'm going to be doing my dy over dx. The power is going to come down to the front. Then I'm going to multiply by the derivative. Now, this is the first time that my derivative, I have more than one x in here. So I'm going to have to differentiate both terms here. The 3 times is with the 4 to make 12x squared. And from the 7x, I would get a plus 7 for the derivative. Then we write the bracket down, the original function, and subtract 1 from the power, will become a power of 8. Okay, next type of question. When using parametric functions, okay, the extension people have done a little bit of work with parametric functions. It just means that we are using a third variable to help us to usually simplify our equations. So when using parametric functions, dy over dx is equal to dy over dt divided by dx over dt. So this is very similar to the chain rule. If you were to do that divide, so dy over dt divided by dx over dt, we know when we divide fractions that we turn the second fraction upside down, and then those dt's would cancel out so that we get dy over dx, which is what we want. Okay, so that's how the rule works. Let's use it for a question. So I'm given two equations. X is equal to t squared and y is equal to 2t. Find the derivative at the point t, which is t squared 2t. Now, it's written as a point there, but notice that the x value, where x equals, is t squared, and the y value is 2t. Okay, so to differentiate, I'm going to need to find the dy over dt and the dx over dt. So I'm going to differentiate each one of those equations. So my first one was x equals t squared. Dx over dt is going to be, bring the 2 down, 2t. Take the second equation, that was y equals 2t. So when I differentiate that, dy over dt would equal 2. So I found the two derivatives, so I can now find my dy over dx, which is dy over dt divided by dx over dt. So subbing in my two derivatives, dy over dt was 2t, and I want to divide that by dx over dt, oops, sorry, dy over dt was 2, dx over dt was the 2t. So the 2's will cancel out, giving me a 1, and I get 1 over t for my derivative, dy over dx. Okay, part B, find the equation of the tangent at t. To find the equation of the tangent, we need a point, which we have up here. We were given the point t squared 2t, and we need a gradient, which is what I've just found here, the 1 over t. The derivative is the gradient. So using the point gradient formula, y minus y1 equals m, x take away x1. Subbing in y take away y1 will be the 2t equals m, which is 1 over t, bracket x take x1, which is t squared. Okay, so I can expand that out. Y minus 2t equals 1 over t times x would be x over t. 1 over t times t squared would be just t, or minus t, because there's a minus sign there as well. And finally, I could get the y by itself by adding the 2t across the other side. So that will add to this minus t term here. So it'll be minus t plus 2t would make a plus t. So there is my equation of the tangent. Part C, find the x-intercept of A, the x-intercept which we're calling A of the tangent t. So if we want to find the x-intercept, we want to sub when y equals 0 into our equation. This is the equation of our tangent. So this was the one we found just up here. So the y equals x over t plus t. So subbing in 0 for y, I get 0 equals x over t plus t. So I want to get x by itself. I'm going to leave the x over t and subtract the other t across the other side. And then I could times my denominator across. T times t becomes t squared, so minus t squared. So that means that my coordinates for A, which was my x-intercept, the x value is minus t squared, and of course y is 0. Part D, find the midpoint, which we're calling m, of AT. Why does m lie on the y-axis? So let's have a look. We have the point A, which was minus t squared 0, and we have the point T, which was t squared 2t. So if I want to find the midpoint, then our formula is x1 plus x2 over 2, y1 plus y2 over 2. So adding the x values, I have minus t squared plus t squared over 2. Adding the y values, 0 plus 2t over 2. Minus t squared plus t squared is 0. 0 divided by 2 is still 0. 0 plus 2t for the y value is 2t, divided by 2 becomes t. Okay, so there we go. We found the midpoint, and it does lie on the y-axis because we had a minus t squared plus t squared cancelling out in there. Part E, eliminate t to show that the curve is y squared equals 4x. So to eliminate the t, you want to rearrange one of the equations to get the t by itself. So my equations were, this is way back from the start, x was equal to t squared. That was my first equation. and the second equation was y equals 2t. So this second equation is easy to get the t by itself. All I have to do is divide that 2 away. So t is equal to y over 2. That's equation 2. And now I can do a substitution method to eliminate that t. So I'm going to sub equation 2 into equation 1. I'm going to do it over here. So equation 2, this part here, is going to go into the t part of equation 1. So it will be x equals, instead of t, it's y over 2 all squared. When I square that, I get y squared over 4. And timesing the 4 to the other side, I get y squared equals 4x, which is what we were expecting to get. Then there's a little note here. It says, suppose that y is a function of x and x is a function of t, then dy over dx equals 1 over dx over dt. So let's have a look at this next question. Differentiate y equals square root of x by forming the inverse function and differentiating it. Okay, so what this is saying is, instead of differentiating y equals the square root of x, because square root of x is not particularly nice, let's square both sides. So squaring the y, I'd get y squared, and squaring the square root of x means I get a normal x. So that means I have an equation where x equals y squared. I could differentiate the x with respect to y because my letters are around the reverse order to what I'm used to. So that means the 2 would come down and it would be 2y. But I don't want dx over dy, I actually want dy over dx. So that means I'm going to therefore find that by taking reciprocals. Okay, so therefore by taking the reciprocals of both sides, I get dy over dx, which is what I wanted, and the reciprocal of 2y would be 1 over 2y. But also, I don't really want to have a y in my equation here, I want x. Remember that y is equal to square root of x, so I can sub that back in to be 1 over square root of x. And there is my derivative dy over dx.